Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about serial in parallel out shift register. Serial in parallel out shift register is one in which the data is passed in serially into the flip-flop and the outputs are fetched out in a parallel manner. The data is passed bit by bit in the register, and when the one data is passed to the register, the outputs are enabled and the flip-flops contain the return value. So before going into how the shift register works, we will see some key terminologies. So we know that shift register is a sequential logic device that stores and shifts the data bits. It consists of a chain of flip-flops which are connected in series. It has a serial input line through which the data is entered into the shift register one bit at a time, and the output lines through which the stored data in the shift register is accessed simultaneously, with each output line corresponding to the flip-flop in the register, giving a parallel output. Next important thing is the clock signal. Here, the timing signal that controls the shifting of the data within the shift register. The rising or falling edge of the clock signal triggers the transfer of data from one flip-flop to the next. Next, we'll see how the data is shifted in the shift mode. So it's a mode of operation in which the data bits are serially shifted through the flip-flops, with the new data bit entering the first flip-flop while the existing data bits shift to subsequent flip-flops. Then in parallel mode, is a mode of operation which the shift registers holds the data in a fixed state, allowing parallel loading of data. The data bits are directly applied to the parallel inputs of each flip-flop. So you know that flip-flop is a fundamental building block of the shift register that stores a single bit of data. It can be in one or two stable states, 0 or 1, and can retain the state until changed by an input signal. Next one, buffering is possible here. There's a process of using a shift register as a temporary storage buffer for data transfer between different devices operating at different speeds. The use of SIPO shift register for selecting specific memory location or devices based on their addresses, allowing efficient data retrieval or storage. The application of the shift register in control systems for storing and shifting control signals, enabling sequential operations and timing synchronizations. Next, we'll see the block diagram of a shift register, which is a 4-bit serial in parallel out shift register. Here, the circuit is having 4 D flip-flops, which contains a clear and clock signal to reset these 4 flip-flops. In SIPO, the input of the second flip-flop is the output of the first flip-flop, and so on. So the same clock pulse is applied to each flip-flop since the flip-flops synchronize each other. Parallel outputs are used for communication. So the basic operation of SIPO shift register involves the sequential transfer of data bit through a series of flip-flops. The register has one input line called the serial input and parallel output lines Q0, Q1, Q2, and Q3 corresponding to each flip-flop. The clock controls the shifting of data. So here the serial input is the entry point for the data into the shift register. The data bits are fed into the first flip-flop in the register. On each clock pulse, the data bit at the serial input is transferred to the first flip-flop, and the existing data in the register shifts one by one position. And the parallel outputs provide access to the stored data in the shift register. Each flip-flop's output is connected to a separate output line, enabling simultaneous access to the stored data bits. The clock signal synchronizes the shifting of the data within the shift register. Typically, the clock edge triggers the transfer of data from one flip-flop to the next. The rising or falling edge of the clock signal can be used depending on the specific implementation and requirements. Here there are two modes of operation. First is shift mode and then parallel load mode. Shift mode, the input data is serially shifted through the flip-flops. The data bits at the serial input enters the first flip-flop, while the existing data bits are shifted subsequent flip-flops. This mode is useful when serial data is need to be processed sequentially. Another one is the parallel load mode. The shift registers holds the data in a fixed state, allowing parallel loading of data. The data bits are directly applied to the parallel inputs of each flip-flop. When the clock signal is activated, the data is latched into the respective flip-flops simultaneously. So this mode is beneficial when data needs to be loaded in parallel. So parallel load mode is used in parallel in serial out and parallel in parallel out shift registers. Next, so this is the truth table of serial in parallel out shift register. So as we have discussed earlier, each and every bit is shifted to the next flip-flop whenever a clock pulse is given and output is taken in all the four flip-flop outputs. Next, we'll see few applications of serial in parallel out shift register. So it's used in data storage and buffering. It's used in serial to parallel conversion. It's used in address decoding, and it's also used in control systems. Let us take some assessment questions. The full form of SIPO is, yes, the answer is serial in parallel out shift register. How can parallel data be taken out of a shift register simultaneously? The answer is, you are using the Q input of each flip-flop to take the parallel output. Thank you for watching this video.